All right, so today is about that hardcore factoring that I told you we'd deal with soon. Well, we're dealing with it today. So do you remember how to factor? Like, can this be factored? Hmm, it's kind of icky, but it can be factored. All right, so let's go back to factoring 101 and make sure we kind of build a base for this. So 2x plus 8, please just factor that. We'll start with the easiest kind and move up to the brutal kind at the end, but we'll step you up one step at a time. Kind of the whole frog in the warm water thing. You know what I'm talking about? Okay, we put a frog in warm water. They are, I believe it's called poikiothermic, where they adjust to the temperature around them, right? So then if it's warm out, their body temperature adjusts. Do we do that? Do we adjust our body temperature? No, our body temperature stays 98.6, and if we go out in a cold place, we better keep ourselves warm or we're going to die. The frogs can adjust their temperature to the surroundings, and so you put them in the warm water, and you can slowly warm up the water, and they won't even jump out, even if it gets hot in there, because they're used to it. Their body temperature is used to it. All right, so I'm going to get you used to factoring here. Slowly warm it up by making them harder, but hopefully you got x plus 4. Please tell me you could factor that. Okay, good. And why would we want to factor? If it's set equal to 0, then it's a great way of solving. Then I just know that that part right there gives me my one answer, which is that x could be -4, right? Some people go, but shouldn't the 2 give you an answer? How am I expected to get 2 answers for this? That doesn't make any sense. I should only get 1 answer for this because this got to the 1. All right, so I get my 1 answer from here. No, that 2 can't be made equal to 0. If it was a 2x, then you could find an answer for that one too. All right, and then that would mean this was a 2x squared plus 8x, and then 2x got factored out. Anyway, let's move up to the next level of factoring. X squared minus 16. There's only 2 numbers, but you end up with 2 sets of parentheses. Do you remember that one? Or do you dismember that one? Good Halloween joke. Row 3, person 1, that's you. What do you think? And if you look at the original, how many solutions would you expect to have? 2, and then we've got 2. 2 answers are 4 and -4. What are they in a big picture? They are a picture of it touching at 4 and -4. That makes sense to you? That's a quadratic that's being factored. All right, what about this? Is this in factored form? Yeah, that is in factored form. It'd be icky if I had to have factored it, but you're going to be able to do factoring not quite as intense as that, but you're going to be able to take things that were huge, x to the how many? Well, let's see. That's x to the 3rd plus another x to the 1 plus another 2x to the 1, and the lead coefficient would have been 2x to the 1, 2, 5, 3, 4, 5, yes. 2x to the 5th would be the lead coefficient on that one. In other words, that problem would have started with 2x to the 5th plus blah, 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 and it would have ended with, well, the number at the end would have been a 1 to the 1. The number at the end would have been some big constant, and it would factor to this. What did I learn from these factors? This was yesterday. I would have learned that this thing hit at, that one's not quite as nice, 2x plus 1 equals 0, 2x equals -1, x equals -1/2. It would have hit at -1/2 right there. This one would have hit at 5. This one would have hit at -7. And it would have been a big wave that kind of goes like this sort of a thing, except that was about as bad as I've ever done. I'm going to make it a triple at the -7. So let's say that's kind of like this. And then it cuts through here and it cuts through there. Could that be possibly right? You could tune it in better even by finding the y-intercept, etc. All right, so how do you get things that are super complicated to factor? Well, there's a way. Let's move up the factoring scale here to this. X to the 3rd plus 2x squared plus 4x plus 8. Do you remember factoring things like this? We can factor this by grouping. Can you try grouping the first two terms? Grouping the second two terms? See if you can do the factor by grouping. Then we'll move into synthetic. I'll pause for a second while you try this one. Okay, I don't want to make you wait too long before I show you this, because if you're stumped, you're just sitting there. So there's an x squared in both of these. I factor out the x squared, and I see what I have left. I have x plus 2 left. Over here, there's a 4 in both of them, so I take it out. I'm going to put a positive 4, because there's a plus sign right here, right? Plus 4 times x plus 2. Then, the x plus 2's are in, there's one in this term, and there's one in that term. So those x plus 2's can be factored out to the front. And then when I factor them to the front, what I'm really doing is dividing the whole thing by x plus 2. That makes this cancel, and this cancel. And then I have what left? X squared plus 4. Now, if you're like, I don't think you're right, Mr. Trevor. I think this is supposed to be squared. Then you're like a lot of people, but you're wrong. Let me show you why. When we factor something out, simpler, like if I had 2x plus 4 and there was a 2 in both of them, did I ever say it was 2 squared because there was one in each of them? I never did that. No, it's not. There's not a 2. There's not a squared here. There was one in each of them. I factored it out to the front. Simple as that. Okay. Now, if this was my question and I said equals 0, could you solve it? Well, you could find one answer really easy, and that's this guy's answer, and that's what could make it equal 0 is if x was negative 2. Do you get that? Well, I'm supposed to have how many answers? Look at the beginning. I'm supposed to have 3 answers. That's only one of them. There's 2 more answers buried in here. But how on earth can you get x squared plus 4 to equal 0? You can solve it. You just have to be able to handle imaginary numbers. Do you remember square roots of negatives? You need that to come back. Square root of square root of x squared is the absolute value of x. We've gone over this. It is not just x. Remember me making you graph it? Square root of x squared came out and you looked like this and you're like, oh, I guess it is an absolute value. Okay? And that equals, and the square root of 4 is 2, but you can't just say 2 because there was a negative in there. So it's really the square root of negative 1 times the square root of 4. That's 2, and that's I, so it's 2i. And then to finish it, x is 2i, and x is negative 2i. And yes, you could say plus and minus 2i. So there's all 3 answers. That's why we need to be able to factor, is to be able to get answers like that. The first one was simple. It was x is negative 2. And then the second ones are more complicated, 2i and negative 2i. What happens if I put in a 2i? It makes this 0. Watch. I put a 2i right there. It becomes 4i squared. And do you remember what I squared equals? I squared is negative 1. So if this becomes 4i squared, and I squared is equal to negative 1, you should know that one. It's one of those things that's going to come up on the ACT someday. They'll have something with an I squared in it, and you got to know, oh yeah, that's negative 1. That's something you learned last year. I know you did because we're teaching it again this year. All right, so 4 times negative 1 makes negative 4. Negative 4 plus 4 makes 0. It makes the whole thing 0 if I put in 2i. That's why 2i is a solution. Okay, so that got kind of intense. The morals of the story, if you have this, what was it again? 4x plus 8. Is that right? Was that what I started with? You can solve it by the grouping thing, but you can also solve it with something called a certain kind of division. Do you remember it? Synthetic division. Good. Okay, so if we have synthetic division to solve this, I need to do this. Everybody write this one down. You're going to want to follow me on this. You put a little box like this, and we need to tell you that, oh, by the way, when you factor this, this certain thing is a root. We need to tell you what the zero, one of the zeros is. If I said, for instance, when I got this thing factored, it was going to have x plus 2 in it. Do you remember that? Do you remember that it had an x plus 2 in it? Then what's the root for that factor? This is the factor, and the other factor, I think, if I remember right, was x squared plus 4, if my short-term memory serves me correct. Is that right? Okay, so we already know the answer. That you're not going to know the answer, but you're going to be told that one of these factors was x plus 2, which should tell you that the root of that is negative 2. The roots are the zeros, the solutions. Negative 2. So negative 2 goes in it. They'll have to tell you that. We aren't going to make you, there's actually a way where you have to like do the factors of the constant over the factors of the coefficient, and you can divide them out and figure out what the possible roots are, and we're not going to do all of that to you. We'll tell you either the factor, which would have been x plus 2, or we'll tell you the root directly and just say, oh, by the way, negative 2 works. And then you can use long division, or this is called synthetic division, to solve it. So I'm going to put, that's a 1, that's a 2, that's a 4, and that's an 8, and they go here. 1, 2, 4, 8. Draw the line. When I taught this last year, this is just a review, so I'm not going to break out the Snoop Dogg song, but drop it like it's hot. And then multiply, and it goes here. See if you can finish the synthetic. Maybe it's been too long and you're going to have to just totally learn it over again, but see if you can get the synthetic division done without me first. All right, in case this has also been too long, you need to know this for your next test, so follow me. You multiply this. What's 1 times negative 2? Negative 2. Then what do you do to these two? You add them. We get 0. Then you multiply, catching on to the pattern here. You multiply, which makes 0. You add them straight down, and that makes 4. You multiply by negative 2, makes negative 8. You add them straight down, and if you get a 0, that means that it works. And a lot of times, kids are like, okay, so it worked, but I have no idea what the answer means. This part here is a factor. Remember how if it's negative 2 was the root, then it was x plus 2 for that. So this means x plus 2. And this part here, not the remainder part, but the other part, this is how many x's you had, and this is how many x squareds you had, and that's your constant. And if there's no number, no sign in front of it, that assumes positive, right? So that's how I get x squared plus 4. There. That's synthetic division for factoring. Now I'm going to show you another one, because I'm not naive enough to think that that alone is going to bring you all the way back to being good at synthetic division. All right, let's try another one. 3x to the third plus 6x squared plus x plus 2. And I will tell you that negative 2 is the root. See if you can do synthetic division on this puppy. Negative 2 is the root. All right, I'm going to pair you with somebody to work on this. So let's see if you did it right. First of all, these get copied down. 3, 6, I hope you didn't put an x. 1 and 2. And then drop it like it's hot, because otherwise you don't know how to start. Then multiply, add, multiply, add, multiply, add, and you got a 0 at the end. Then that means this part is part of your answer, and this part gives you a hint. Now I want you to write what the actual answer is. If you did that, all you did was the work. What's the answer? The answer is you factored it. Whether you know it or not, you just factored this guy. So write what you think the answer is. What times what? The minus 2 led to x plus 2 would be that factor. And the other one is this is how many x's, this is how many x squared you had, so it's 3x squared plus 1. Raise your hand if you had that correct. Okay, good. Then you have reminded yourself how to factor using synthetic division. All right, now let's see if you can actually use that. I think we're ready for this actual problem here. I'd like you to take that, and it tells you the factor and the root. Would you please use synthetic division? Hint, I know you know what goes in the little thingy here, but if you just do 1 and 27, it will not work. Try to remember what to do for here, 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 and here. Those 4 numbers are not immediately apparent. Hint, placeholders. Remember using placeholders? I'll pause for a moment while you give this a shot. At a minimum, at least tell me this. You knew that this is a 3, right? Because it said that the root was 3. Factor is x minus 3, so you knew that's a 3, right? And you start with a 1. I'm going to pause while you try to figure this out. I'm hoping that you remembered that this would be the x to the 3rd spot, this would be the x to the 2nd spot, this would be the x spot, and this would be the constant. So, in the other one, we always had one of each term. In this case, we don't have any x squareds. So how many x squareds do we have? 0 x squareds, and we have 0 x's. So you needed to say 0, 0, and 27. Raise your hand if you actually remembered that. Ooh, a lot of you did. Sweet. Okay, then how do we start? Ask Snoop Dogg. Drop it like it's hot. Then that gets multiplied as 3. Add them, multiply them, add them, multiply them. Uh-oh. Ah, the slide was wrong. You are correct. 3 is not a root. It must have been a negative 3, which means x plus 3 is the factor. My slide is wrong. I apologize. Negative 3 should be the root. Let's just make sure that actually works. Negative 3, that would be negative 3. Multiply it, makes it positive 9. Add them down. Now when you multiply it, it makes negative 27. Then it has a 0 root. Cool. Awesome. Now I can actually, and I apologize, that's just, yeah. You're my first honors pre-calc class of the day, so any mistakes in the slides, I'll catch it in your hour, and I'll look smarter 6th hour. Okay. Sorry about that. X plus 3, and then this part would be x squared minus 3x plus 9. Now, this does not guarantee that it's factored all the way. It factored it, but it didn't factor this part. And this part doesn't happen to factor, as in you can't factor it in anything nice. So it's factored as much as it can be, and there we have factored the problem. Okay, so now, what is a typical question for today? Yesterday it was about sketching these guys and saying, okay, it hits here, and maybe it goes like this, and it bounces off there, and then we'd say like, oh, where are the roots of this thing? There we go. The roots of it would have been here, and then we might say things like, when was this function, f of x, when was it greater than 0? We would say, oh, it's greater than 0 between here, and from here to infinity. Okay, that's kind of where we were, but then we were always giving them to you pre-factored. What if we don't factor it, and you have to factor it? See what I'm saying? You have to factor it, and then you get this thing that isn't factored that starts off looking like this. And then you have to factor it, and then you can sketch it, and then you can figure out what intervals causes this to be greater than or equal to 0. See what I'm saying? So it's just, we're just adding in the extra tool of you have to know how to factor heavy-duty stuff so that you can then get the next answers. All right. So now let's get to one. Would you please do this one? We practiced these yesterday, and notice it's already factored for you. Yay. Don't have to go through that intense factoring process. Make it bounce in the right place. And then we're going to talk about writing a limit statement for the end of the function. It's the next thing I have to teach you. Notice it's got a negative on the lead term. Remember that tells you that the right-hand side is down. Don't forget that your function ends going down. All right, and pause while you sketch that puppy. Okay, so what are the roots here anyway? Is that 5 a root? No, that's not a root. You can't make 5 equal 0. Very good. That I could make equal 0, so that's one of my roots, and that's one of my roots. And can I make an x equal 0? Yeah, that's one of my roots too. If you didn't notice, there's 3 spots it touches, 3 roots. One of them is at -2. So let's say that I mark these things as that's -2, and I touch it right there. And you could have picked another spot to be -2, doesn't matter. And this one's going to be +1. Let's say I make this +1 right here. I'll move that over. There we go. That's an important spot. And the other important spot's at 0. Those are my 3 important spots. 0, 1, and -2. Okay. Now where is it bouncing? 2 spots. Remember that even ones act the same. They both kind of look like parabolas. So it's going to be bouncing at those 2 spots, 0 and 1. And I need to know how it ends. It ends going down. So if it's ending going down, then the bounce must have happened this way. And if it's going to bounce again, it must have happened that way. And then it looks like it should be going up on the left. Let's see if that would make sense. If I find the lead coefficient on this thing, it'd be x to the 3rd for this part, x to the 4th for that part, and x to the 2nd for that part. Put them all together, that's an x to the 9th. Does an odd power make sense with one end up and one end down? Yeah, cool. Okay, there we go. There's my sketch. Now, what is it talking about for the limit statement? Instead of just using caveman words like up, down, we can say things in a much more mathematically accurate way. Like, the limit of this function as x approaches infinity is infinity. All right, have you ever heard of a limit before? All right, so I'm going to start you off with a simpler one. Let's say that I got a function that kind of looks, let's go like that one. Would you agree on the right-hand side, it just keeps going up and up and up and up? Okay. On the left-hand side, it keeps going down, down, down. So the right end limit, is there a limit? No, but we can still write what's called a limit statement. The lim of this function. And now, do you agree that there's the right side limit is different than the left side limit? So we need to delineate the limit of this function on the right side, which would be as x approaches 0. The limit of this function as x approaches 0. I did that wrong. X approaches infinity. Sorry. Now let me show you why I knew I was wrong. On the right side, missing a t up here. On the right end, x, which is down here, as it gets bigger and bigger, x starts to approach, if I extend it forever, it starts to approach infinity. That's why I'm saying that the right end is where x approaches infinity. Do you get that that kind of goes together? The right side would be where x approaches infinity. What would the left side logically be then? This is my left end limit. The limit of the function as x approaches what? Guys, pay attention. The limit of this function on the left end would be as x doesn't approach 0. If you go way to the left, what's x approach? Negative infinity. On the way right side, what's x approach? On the way left end, what is x approach? Negative infinity. All right. Now, what is the actual answer to this limit statement? I'm saying the limit of my function as x approaches infinity is, and you have to say equals, and then it's usually either infinity or negative infinity. There are some functions that will get closer and closer and closer to 0. So that's another common answer. The limit of the function might get close to 0. But in this case, if I go way that way, that's on the x. The y value, when I get there, would be way up here. And so it's positive infinity. So here it is, all written out, the limit of this function as x approaches infinity. Now this is important. You can't just put that anywhere. It's got to all be under the word lim. Why am I being picky? Because next year you're going to be in calculus, whether it be IB version or AP version. And when you write out your answers on the AP calculus test, which you will take whether you're in IB or AP, they have to have this all in one block. Some kids are like, well, I write it this way. Lim as x approaches infinity. Well, then you get it wrong, because on the test they won't take that. You got to get used to putting it right underneath the word lim. The limit as x approaches infinity of the function is, I need to finish it, and again, usually the answer is infinity or negative infinity. Either the function is going way up at the end or it's going way down at the end. And in rare cases, like I'll make you a little tiny sketch. Did you get that there are some functions that go like this and get closer and closer and closer to 0? Then the limit of that function way on the right would be 0. But usually it's infinity or negative infinity. Okay, so the limit of this function is, I follow it right here. That function is getting higher and higher, and therefore its limit as on the right end would be infinity. On the left end, which is x is going towards negative infinity, it'd be negative infinity. Okay, so there's your, you've learned two powerful things today. One is reviewing how to do factoring using two different methods, the grouping method or also the factoring with synthetic division. And we've talked about how to write a limit statement. But I'm not sure you're actually good at the limit thing yet. Let me show you one. Here's a quadratic that you're used to. What's its left end limit? Write me the limit statement for the left end. This would be like too easy for an AP calculus test. Not even close to hard enough. But it's the pretty decent for your first limit question you do on your own. Okay, you should have said the lim of the function. And where does the x approaches go? Underneath the word lim. And if it's the left end, what is x approaching on the left? It's way over here, so it is x approaching negative infinity. And the limit of that function, when I get way, way over to the left, what's the y value? We've already said the x value would be close to negative infinity. What would the y value be there? It's really, really high up, right? That's positive infinity. If you said negative infinity, that's implying the end would be way down low, like down here. And it's not. So I know some of you are thinking, but that's on the left side. It's talking about how high it is. It's the y value of it. All right. Now let's look at this is another synthetic division question, but I'm starting to run out of time here. So I think we should start looking at your homework. So here we go. Now it's asking you to do polynomial long division, and you can also use synthetic division for that. But I'm going to have you do this first one with synthetic. You should be able to use synthetic on that. Skip the others. We're going to do synthetic on this and this. Remember to use placeholders on this one, as in zeros, like it has 0x squareds and 0x's. Okay. Only doing the ones I'm circling here. We are not doing a remainder theorem yet. All right. So it says do together, as in you're not going to do it at home. This one is factorable, but holy cow. That with a multiplicity of 2, I think that's a little too intense for right now. So we'll skip those. This is a good stretch question, and you can do it with synthetic. Let's do 8. And that's it. And that's all I have for you for today. Any other questions? All right.